The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. But even if 10 isn't the top of the scale, it might as well be. A magnitude 9 earthquake already measurably alters the rotation of the Earth. The 2 magnitude 9 plus earthquakes this century both altered the length of the day by a tiny but measurable fraction of a second. In order to get to magnitude 10, you'd need a ruptured fault line 3,500 kilometers long, and a magnitude 11 quake would require a fault that went halfway around the world. A magnitude 15 earthquake would be 1,000,000 times more powerful than that, and involve the release of enough energy to evaporate all the water on Earth. Though if that happened, we could rest easy knowing the earthquake couldn't cause any tsunamis. Going a few steps further, a magnitude 18 earthquake would release nearly 10 to the 32 joules of energy, which is roughly the gravitational binding energy of the Earth. To put it another way, the Death Star caused a magnitude 18 earthquake on Alderaan. You could in theory talk about a more powerful earthquake on Earth, but in practice all it would mean is that the expanding cloud of space debris would be faster and hotter.